A heterocyclic compound or ring structure is a cyclic compound that has atoms of at least two different elements as members of its ring, S. Heterocyclic chemistry is the branch of chemistry dealing with the synthesis, properties and applications of these heterocycles. In contrast, the rings of homocyclic compounds consist entirely of atoms of the same element. Although heterocyclic compounds may be inorganic, most contain at least one carbon. While atoms that are neither carbon nor hydrogen are normally referred to in organic chemistry as heteroatoms, this is usually in comparison to the all-carbon backbone. But this does not prevent a compound such as borazine from being labeled heterocyclic. IUPAC recommends the Hans-Widman nomenclature for naming heterocyclic compounds. Classification based on electronic structure. Heterocyclic compounds can be usefully classified based on their electronic structure. The saturated heterocycles behave like the acyclic derivatives. Thus, piperidine and tetrahydrofuran are conventional amines and ethers, with modified steric profiles. Therefore, the study of heterocyclic chemistry focuses especially on unsaturated derivatives, and the preponderance of work and applications involves unstrained 5- and 6-membered rings. Included are pyridine, phyphene, pyrrole, and furan. Another large class of heterocycles are fused to benzene rings, which for pyridine, phyphene, pyrrole, and furan are quinolin, benzothiophene, indole, and benzofuran, respectively. Fusion of two benzene rings gives rise to a third large family of compounds, respectively the acridine, dibenzothiophene, carbazole, and dibenzofuran. The unsaturated rings can be classified according to the participation of the heteroatom in the pi system. 3-membered rings, heterocycles with 3 atoms in the ring are more reactive because of ring strain. Those containing 1 heteroatom are, in general, stable. Those with 2 heteroatoms are more likely to occur as reactive intermediates. Common 3-membered heterocycles with 1 heteroatom are, those with 2 heteroatoms include, 4-membered rings, compounds with 1 heteroatom, compounds with 2 heteroatoms, 5-membered rings, with heterocycles containing 5 atoms. The unsaturated compounds are frequently more stable because of aromaticity. 5-membered rings with 1 heteroatom, the 5-membered ring compounds containing 2 heteroatoms, at least one of which is nitrogen, are collectively called azoles. Thiazoles and isothiazoles contain a sulfur and a nitrogen atom in the ring. Dithiolanes have 2 sulfur atoms. A large group of 5-membered ring compounds with 3 heteroatoms also exists. One example is dithiazoles that contain 2 sulfur and a nitrogen atom. 5-member ring compounds with 4 heteroatoms, with 5 heteroatoms, the compound may be considered inorganic rather than heterocyclic. Pentazole is the all-nitrogen heteroatom unsaturated compound. 6-membered rings, 6-membered rings with a single heteroatom, with 2 heteroatoms, with 3 heteroatoms, with 4 heteroatoms. The hypothetical compound with 6 nitrogen heteroatoms would be hexazyme. 7-membered rings, with 7-membered rings, the heteroatom must be able to provide an empty pi orbital for normal aromatic stabilization to be available. Otherwise, homoaromaticity may be possible. Compounds with 1 heteroatom include, those with 2 heteroatoms include, 8-membered rings. Images, names in italics are retained by IUPAC and they do not follow the Hans-Widman nomenclature. Fused rings, heterocyclic ring systems that are formally derived by fusion with other rings either carbocyclic or heterocyclic, have a variety of common and systematic names. For example, with the benzo-fused unsaturated nitrogen heterocycles, pyrrole provides indole or isoindole depending on the orientation. The pyridine analog is quinolin or isoquinolin. For azpine, benzodiazepine is the preferred name. Likewise, the compounds with 2 benzene rings fused to the central heterocycle are carbazole, acridine, and dibenzodiazepine. History of heterocyclic chemistry. The history of heterocyclic chemistry began in the 1800s, in step with the development of organic chemistry. Some noteworthy developments: 1818 Bruignatelli isolates aloxane from uric acid, 1832, Doberina produces furfural by treating starch with sulfuric acid. 1834, Runge obtains pyrrole by dry distillation of bones. 1906, Friedlander synthesizes indigo dye, allowing synthetic chemistry to displace a large agricultural industry. 1936, Tribes isolates chlorophyll derivatives from crude oil, explaining the biological origin of petroleum. 1951, Chargay's rules are described, highlighting the role of heterocyclic compounds in the genetic code. Commercial exploitation, leading companies with a vast number of patents related to heterocyclic compounds are Bayer, Merck, Cuba JG, Pfizer, Eli Lilly, BASF, Hoffmann La Roche, ER Skib, Warner Lambert and Hearst. References. External links, Hans Widman Nomenclature, IUPAC, Heterocyclic amines in cooked meat, USCDC, List of known and probable carcinogens, American Cancer Society, List of known carcinogens by the State of California, Proposition 65.